Welcome to a small video series on the implementation slash deployment of Federated Learning Framework using Flower tool. Flower is an open source tool for Federated learning simulations and real-time deployment. My name is Amir Anis. I'm a postdoc researcher at University of New South Wales. In this series, we are going to cover four specific parts, which will be illustrated in the subsequent four videos. The first two parts are on the implementation of Federated Learning framework using Flower tool on the same local machine, first using raw Python files and then using Docker files. The third and fourth parts are on the implementation of this Flower tool on the Nectar cloud instead of the local machine. Again, first using raw Python files and then using Docker files. The first part, which will be covered in this video, is on the implementation on the local machine using Python files. The Federated learning environment or setting is such that we are going to have one server which is responsible for communicating and aggregating local model parameters from the participating clients, and then there are three participating clients are responsible for local training and exchanging model parameters with the server. So we are going to understand the Python code for the server and the clients, and after that we are going to run these Python files on the same local machine. This example or this piece of code has been taken from the official GitHub page of Flower, which is present under the section of examples labeled as quick start PyTorch. They have the Python files for the client and server. Apart from that, it has pyproject.toml, which lists the requirements in terms of the libraries need to be installed before we can run that, and one readme.md file which lists the in detail instructions to run this example. This specific example, which is mentioned on their official page, is intended for the digital images. The data being used or the type of data being used is images. What we have done, we have modified this code a bit such that our example is working with the tabular data. The tabular data is present in a CSV file, those numerical data instead of the images data. So let's have a look at the Python files that we have in our folder. We have this same pyproject.toml file, which lists the metadata and some of the packages need to install before we can run that. And then we have these three client files. Instead of one client Python file, we have these three client files for the three participating clients. And then we have this server Python file responsible for aggregating those different local model parameters. Before I can go over through these Python files, let's have a quick look at the tabular data that we have for each of the client. So there are three participating clients, and each client will have its own piece of local data set. The first CSV file, which is on the left side, is for the first client labeled as data_1.csv. This middle one is labeled as data_2.csv for the second client, and this one, which is on the right side, is the third data file labeled as data_3.csv for the third client. We can see that the columns in these three features are constant. The first four columns of these CSV files corresponds to the input features, which are labeled as feature A, feature B, feature C, and feature D. And the fifth column, which is labeled as label, corresponds to the output feature. So all of these three CSV files, these three local data set files, have the same number of input features, including the output feature. The number of data points, however, can be different from one to another. For example, in the first CSV file, it has around about 450 data points, and if we see the third CSV file, it has around about 475 data points. So the number of data points across these participating clients can differ from one to another, but the number of input features including the output feature, should remain the same across these participating clients. So back to the code. This client underscore one.py, this Python file for the first client begins with importing a bunch of libraries which will be used in this Python file. Then we have this load data method, a function used to load the data and do a bit of pre-processing. It is loading a data from this local directory of data and reading this data underscore one.csv file. Then we are splitting this data into the input and output and further into the training and the testing data set. Then we have this class net, which is used to define the architecture of the neural network being used. We are going to have two sequential hidden layers with the sizes being defined using these variables, and after these linear layers, we are going to have ReLU activation function for these linear hidden layers. Then we have this train method used to train the neural network machine learning model on the training data. We have defined a bunch of hyperparameters here, such as learning rate, the loss, the optimizer, and so on and so forth. And here we are training our model for a number of epochs. And then we have this testing method used to test or evaluate the model on the testing data set. So these 4 or 3 methods, and then we have this class, is kind of the same methods, including this class, as compared to what we have in a centralized way. So if we apply a certain problem of a machine learning model in a centralized way, we have the same kind of methods in that Python file as well. The loading of the data, then the training and the testing and defining the architecture of the neural network kind of remain the same in a centralized setting as well. The only difference as compared to the centralized one is that we are going to have this Flower client class, which is inherent from the NumPy client defined in the Flower library. In this class, we are going to have these 4 different methods. The first one is the get underscore parameters method, which is used to get the local model parameters from the server. Then this set underscore parameters is used to send the local model parameters to the server. This fit method is to train the machine learning model received from the server. And finally, this evaluate method is used to evaluate the performance of the model on the local testing data set. And then we are defining this function for the client underscore fn. And finally, we are running this client by using the start underscore client method, and in that we are specifying the address of the server, the IP address, including the port number. As we are going to run this example on the same local machine, that's why the IP address is 127.0.0.1. But if we have to run this on a physically distributed machine, then we need to specify the actual IP address of the server. For the other 2 files, for other 2 clients, client 2 and client 3, the Python files remain the same. The only difference is this data file. The client 2 is reading data underscore 2.csv file instead of the first one. And similarly for the client underscore 3, everything remains the same except of this data underscore 3.csv file. For the server, again, we are going to have a bunch of import files for the libraries that we are going to use in this Python file. Then we are defining a method for aggregating the local models received from the clients. We are defining a weighted average strategy. It can be a simple average, it can be a weighted average, or it can be some other kind of aggregation method. There are a ton of different aggregation methods available in the literature. Then we are using this fed average method, in which we are defining a bunch of parameters, the aggregation method being used. In this case, it's weighted average, and then the number of participating clients, which is 3 in this case, and number of rounds for the training is set to 50. And finally, we are initializing or starting the server by specifying the server address, the IP address, and the port number. So again, it's on the same local machine. That's why we have port 0.0.0.0, and the port number 5007 has to be same across the 3 participating clients and the server. So that's the very brief overview of these Python files for the client and server. Let's run these files on the same local machine. So I'm in the directory where these Python files are present at the moment. So first of all, I'm going to run the server Python file by specifying Python 3 and then the name of that Python file, which is server.py in this case. So I'm going to run that. It will take a bit of time to run this. Once the server is up and running, we can start running the client files, because client has to connect to the server to exchange those model parameters and do the local training and stuff like that. I can see that there is something going on. Let's run the first client Python file. Yep. And let's run the other 2 files for the other 2 clients as well. If you see the server side, it's requesting the initial parameters from one random client. So in general, in federated learning setting, the server is one which is responsible for initializing a global model and sending this global model to each of the participating clients. In Flower, a tool, they have implemented in such a way that the server is actually requesting one random client to send the initialized version of the model, which are the initial weights and biased vectors. And after receiving those initial model parameters, the server will send those model parameters to each of the participating clients, and then each of the participating clients will take that random model and it will train on their local data set and send back the trained local model to the server, and so on and so forth. So this process goes for 50 number of rounds, and at the end it shows us the evaluation metrics in terms of loss and accuracy. And for the client, it shows the accuracy on the testing data set that each of the client has. That's pretty much it as far as the first video goes. In the next video, we are going to implement the same FL framework, but using Docker files instead of the raw Python files. Thank you.